This is a tutorial for series and parallel circuits. I have my equations up here at the top, V equal I times R and P equal B times I. I have the two equations for resistance. Resistance for a series circuit is found from adding the sum of each individual resistor together. And then this is the equation for the parallel circuit. All right, first thing we're going to do is solve for this series circuit. Circuit number one has two resistors in series. You know they're series because there's only one pathway around the circuit. And one of the resistors is 20, the second is 30. I've entered that into the spreadsheet. You can create your own spreadsheet if you're doing problems like this. And then I've added the total voltage here. To find the total resistance of the circuit, I'm just going to add 20 plus 30. And that's going to give me my total resistance of 50, and I'm going to fill it into the chart. The next thing I'm going to do is solve for my current. Now in this row, I have the 120 volts and I have the resistance. So if I think about my equation V equal I times R, I'm solving for current. Remember, current is represented with the symbol I, voltage is V, resistance is R, and power is P in our equations. When I plug my variables into this equation, 120 equal I times 50, the rearrangement is going to be divide both sides by 50, and that's going to give me my current of 2.4. All right, we have a series circuit. In a series circuit, the current flows around in a loop, and the current is the same in all spots of the circuit. So I can go ahead and enter 2.4 amps into my chart when I know the total. Now I have two of the variables in each one of these rows. I can solve for the voltage drop across each one of these devices. So the voltage begins at 120. This first resistor uses part of the voltage, flows to this second resistor, and then the second resistor is going to use the remainder of the voltage. I'm going to calculate voltage using, again, Ohm's law, I times R. Current is 2.4 times 20, and that's going to give me 48 volts will be the voltage drop across this device. So this resistor uses 48 of the volts that's supplied by the battery. I'm going to plug that into the chart. The next example is my voltage current is 2.4 and my resistance is 30. So the voltage drop across that device, second device, is going to be 72 volts. So this 30 ohm resistor uses 72 of the volts that are being supplied. And if you notice, these two numbers, 48 and 72, add up to 120 to double check that you've done it correctly. Now I'm going to solve for power. Power is equal to V times I. And I'm going to multiply the voltage of 48 times the current. And that's going to give me a power of 115.2 watts. And plug that into my chart. Second power I'm going to calculate is 72 times 2.4, giving me power of 172.8. And then I'm going to calculate the total power. Power is equal to 120 times 2.4. And my total power produced by this circuit is 288 watts. You will notice these two numbers add up to give me the total as well. Let's move on to the parallel circuit. The parallel circuit has a 20 ohm resistor and a 30 ohm resistor, same two resistors as we had in the previous problem, and the same battery. I've got these entered into the chart. Remember that we have a different equation when we're solving for total resistance in a parallel circuit. So this is the equation we're going to use. You have a key on your calculator, x-1, that does the inverse calculation for you. So let's plug into this equation. 1 over RT equal 1 over 20 plus 1 over 30. And then I'm taking the inverse of that to get the final answer. When we're at this point, 1 over the total resistance is equal to 0.0833. You're going to take the inverse of that number to find the final answer. I'm going to rearrange it to show you what that looks like. RT equal 1 over 0.0833. And the total resistance is going to come out to 12. You know that you've done the total resistance correctly when the final total resistance is less than any one of the individual resistors. So that's a way to check. All right, I have two of the variables in this bottom row. I can solve for the current using Ohm's law, B equal I times R. I know the voltage, 120. I'm solving for current. I have the resistance of 12, and the current's going to end up being 10. All right, thinking about what's true in a parallel circuit. So the current is split. So the current is not going to be the same in each one of these branches if the resistors are different, which these are. The thing that does stay the same is the voltage. So the voltage drops across this circuit. 120 volts is starting out here, and we drop to 0 on the opposite side. So each branch is going to have the same voltage. That means I can fill in my chart like this. Since I have voltage and resistance in each one of these rows, I can now solve for the current. Remember, current is the I in the equation. When I look at this equation, B equal I times R, the equation becomes B divided by R equal I. So let's solve for the 20 ohm resistor. 120 divided by 20 is going to give me a current of 6. 120 divided by 30 is going to give me a current of 4. You will notice that these add up to 10, so you have it checked to see that you've done it correctly. Power is going to be calculated by the equation V times I equal P. So 120 times 6 is going to be 720. 120 times 4 is going to be 480. 120 times 10 is going to be 1200. These add up to give you the 1200 as a check that you've done it correctly. Here we have a parallel circuit with 3 resistors. We have entered them into the table, 20, 30, 40, and the voltage total of the circuit. So remember, as the current flows through, a different amount is going to go through each of these resistors, and the voltage is going to stay the same. Again, our equations, we're going to use V equal I times R, P equal V times I, and 1 over RT equal 1 over R1 plus 1 over R2 plus 1 over R3. So first step will be always to calculate the total resistance. So RT equal, remember we can use that inverse function, 1 over 20 plus 1 over 30 plus 1 over 40. And then we're going to take 1 over that number to get the final answer. And when we look at our calculator, you're going to end up at this space, 1 over RT equal the number 0.1083. You're going to take 1 over that number, 1 over 0.1083. So you're doing a lot of inverse functions here to come up with the final answer. I'm going to report my answer to 3 sig figs. This is the total resistance, also known as the equivalent resistance of this circuit. So anytime I have 2 of the variables, I can solve for the third one. So I have voltage, I have resistance in this row. So I'm going to do V divided by R. equal I. And that's going to leave me with 120 divided by 9.23, giving me a current of 13.0. So that's going to go into my table. And now I have a row filled in, and you think about what I know about the rest of the circuit. And remember, in the first intro to this problem, I said the current is going to be splitting because the resistors are all different values. We're going to have different amounts of current flowing through each branch. So, but we did say that 120 volts goes in, 120 volts goes in, 120 volts goes in. It drops across the resistors. And so each one of those resistors will be using the same voltage. Now I have two variables in each one of these rows. And the thing I do need to remind myself is that when I'm calculating current, I'm calculating the current through the branch. So I'm going to use the resistance of each resistor. Calculating V divided by R equal I. For the first resistor, 120 divided by 20 is going to give me a current of 6 amps. And I did include the units at the top of the table, so that makes it a little easier to think about. 120 divided by 30 is going to give me 4 amps. 120 divided by 40 is going to give me 3 amps. And if I add these currents up, 6 plus 4 plus 3, I end up with the total current that I calculated earlier. So I know I didn't not make a mistake. So power, calculated V times I, voltage times current. So for the first resistor, power is 120 times 6, and that's going to be 720 watts. For the second resistor, still got the same voltage, times 4 amps, and that's going to give me 480 watts. Third resistor, same voltage, current's different, 360 watts. Now I can add these three numbers up to get my total, 1560. And remember, I can also do power is equal to 120 times 13. It's going to give me the same number. So ways to double check that you have calculated everything correctly.